So we're starting off with the new topic of geometry, and whenever we start something new like this, we're really starting off on the ground floor. So this first set of topics that we're going to be talking about are what we're going to be calling the geometry foundations. And this is really kind of laying the groundwork for, everything that we're going to be talking about from here on out for the rest of the year. And it's really going to be giving us, well, what our first topic is called is, the building blocks. So nothing here is going to be too terribly exciting, but it's the things that we need to move forward and use to build and make more complex ideas with. So the very first things that we need to talk about in geometry, there's three big things that are going to build everything else for us. And really, you can make the argument that it's really just the one thing that's going to build everything for us. But the first thing we're going to talk about would be points. So points are the first of the three undefinable things that we're going to talk about. And we say undefinable because they don't really have great definitions to be given. They just kind of are what they are, and we already kind of know what they are. And then everything will be built based off these undefinable items. And so points are just a marking of a location in space. And so it doesn't have any width or depth or breadth. It is just a single point that has no measure. It just has a location. And so when we name them, we'll call this, for example, point A. We usually use an uppercase letter and just say this is the point that I'm referring to. So if I take a bunch of those points and I put them all in order together, what I can form would be a line. Okay, so lines are my second undefinable item, but really what they are just a set of points all strung together. They extend infinitely in two directions, and when we want to name them, we can name them a couple different ways. We could just give this line a name. If I just want to give it a name, for example, line L, we usually use this cursive script, and then I can just refer to it as line L. But more commonly, what we're going to do is we're going to refer to lines by points that actually lie on them. So, for example, if I were to name two of these points, point B and point C, what I can then call this is line BC. And I denote that it's a line by putting a line over those letters. Now, an alternative way of naming this, because the order doesn't matter here, it refers to the same thing, is I could have also called this line CB. No change. Exact same line. Alternatively, if I knew another point on here, it doesn't matter which point I use, I can name this line BD as well. All right? I can name, or I can use any of these points that are on the line to name it. And the order, again, doesn't matter. Now, the question you might ask is, why does it take me 2 points to name a line? And this is actually a really important thing to understand. It's because if I pick any 2 points out in space, how many lines can I draw through them? And the answer is just 1. All right. So, for example, over here, when I name this line BC, there is no other line that can be drawn through those points. It is that line. And so it uniquely refers to just that one line. The last thing, the last undefinable item, is what we call a plane. So a plane is a two-dimensional object that extends infinitely in every direction. And, it's really hard to draw an infinite object, on a two-dimensional surface. And so what we tend to do is kind of draw this like we're looking at it from an angle. And so this is a plane. We can refer to planes in a couple different ways. One is, especially if you're seeing it on a book or something, we could name this in an uppercase bolded letter. It's really hard for me to bold my writing, but I could call this plane R if I wanted to, or more commonly what we'll do is we can name this using 3 non-collinear points. Now, I haven't defined what non-collinear means, but we'll get to it here in a second. You can probably use your context clues. But it's 3 points that don't lie on a line. Because again, if I have these 3 points, the reason I need 3 of them is that if I have 3 points, there is exactly one plane that connects them all. There's no other plane that I could use that contains these 3 points that's different than this one here. There's only the one. And so the reason that it's important to say that it is 3 non-collinear points is that if I pick, for example, B, D, and C up here, there's actually infinitely many planes that would contain those. So these are 3 undefinable building blocks that everything else is going to be built off of. Oh, I forgot to name this. So I could refer to this as plane E, F, G, for example. And that's what we'll most commonly do. And so these are the 3 undefinable items that are really going to build everything else for us. All right, let's see if I can get rid of this layer. And let us talk about some terms. So 2 terms that we want to define here are colinear and coplanar. So colinear, what I was just referring to before, would be points that lie in the same line. What I'll also commonly say is 3 or more points that lie on the same line, because it's not really interesting to talk about 2 points that collinear, because 2 points are always collinear no matter what. Any 2 points you pick can lie on a line. It's more interesting to talk about 3 or more points whenever they lie on the same line. And so, very similar definition, coplanar is points that lie in the same plane. And again, it's really not interesting to talk about 3 points that lie in the same plane, because any 3 points can lie in the same plane. So 4 or more points that lie in the same plane are more interesting to talk about, because if I pick 4 points, for example, let's see if we can sketch this real quick. So if I have a plane which, if I just pick 3 points, necessarily have to lie in it. But if I draw another plane here, let's see if I can do this okay. Then we can pick, for example, maybe I should change my color, a point here, a point here, a point here, but then a point on this plane that there is no plane that can contain all 4 of those points. So they would be non-coplanar. And so that would be the opposite of colinear or coplanar, would be non-collinear or non-coplanar. All right, let's get a new layer. Get rid of this one. And get rid of this. All right, next definition would be a line segment. So a line segment is a segment that, or it consists of all points on a line that lie between 2 endpoints. And so what I mean by that is that if I have a line like this, and I have 2 endpoints on it, I can refer to line AB, which is all of these points, or I can refer to segment AB. And how we name segment AB is the same way that we've named lines, where I'll say my 2 points, my 2 endpoints, and then I'll denote it with a segment across the top. And so this just refers to these points in here that are all the points on this line that lie between my 2 endpoints, A and B. So segments are another one of our common building blocks that we'll use in things like polygons later on. Our next definition, and I should probably get rid of this one first, is arrays, or are arrays. So array consists of an endpoint and then all points that lie on a line to one side of that endpoint. So again, we're using a line kind of the basis of our construction here. And so I'm going to draw a line. And so array consists of an endpoint. So I'll pick a point here. And then all points that lie on a line to one side of that endpoint. So everything on this side. And so I should name this point. I'll call this A. And if I want to name this ray, I need to have another point to use as well. And so I'll pick another point over here. We'll call it B. And so this will be ray A, B. Now, up until now, the order really hasn't mattered whenever we name things, but the order very much matters for rays. So ray AB, what I always start with is the endpoint and then the point that it goes through. And so this is not equivalent to ray BA. BA would start at B and then go in the other direction. So these are not equivalent things. Let's get rid of that. Additionally, I can name this in a different way. If I want to, for example, put another point on here, call it C, this would be the same thing as ray AC. Okay, AB and AC, those rays are the same here because they both start at point A and they go through point B or go through point C. They go in that direction. Additionally, we are not going to name things by flipping the arrow. This is not something that we do. This is a big no. Our arrows will always go to the right. They'll always start with our endpoint and then go through another point. And so I can have two rays if I want to talk about them and call them opposite rays. Those are two rays that share an endpoint and then extend in opposite directions. So if I have a ray, starts at a point, we'll call this ray D, E, and then I have another ray that starts at the same endpoint and then goes in the opposite direction. We'll call this ray F. So rays DE and ray DF would be opposite rays. Okay. Another way of thinking about this is that ray DE and ray DF, what do they form? Well, they form a line. Opposite rays form a line for us. All right. And so then the last definition that we get to talk about would be intersection. So what an intersection is, it's just the set of points that two objects have in common. So that could be two of whatever we want to talk about. If I have two lines, for example, so if I have a line AB and I have a line CD, that might be a little bit dark. Their intersection is whatever this point is here. So point E, for example. Point E would be the intersection between these two lines. In addition, I can have a whole bunch of different things that intersect. And in fact, I drew one earlier when I had my two planes. So if I have two planes, let's draw this again. So if I have a plane and then another plane that intersects it, what my intersection will be this line, which might be counterintuitive because whenever I draw planes, it's really hard for me to show that they're extending infinitely in any direction, but they are. And so that means that my intersection here is not just this segment, but rather this entire line. All right. So those are all the definitions of kind of our building block objects that we're going to use to create a whole bunch of different things later.